No, if I'm live, please show me if I'm live. Please, please, please. Please show me if I'm live. Please, please, please. Okay, I guess I'm live. My internet is quite slow. Okay, I guess I'm live. Leave it, okay. So the next question is merge two sorted lists. Okay, I'll try to solve it as soon as fast as possible. Let's close this down, let's close this down. Okay. So the question is merge two sorted linked lists. Okay, it is already sorted. And return it as a new sorted list. Okay. The new list should be made by splicing together the nodes of first streets. Okay. The question is quite simple. We are having two linked lists. पहला लिंक लिस्ट में 1 2 and 4, दूसरे लिंक लिस्ट में 1 3 and 4 दोनों शॉर्टेड है. हम लोग को नया लिंक लिस्ट बनाना है, मर्ज करना है. ओके सो मैं क्या कह रहा हूँ कि दोनों के लिए हम लोग अगर पॉइंटर रख ले, यहाँ पॉइंट कर रहा है, एक यहाँ पॉइंट कर रहा है, राइट. दोनों को कंपेयर किया, जो एलिमेंट छोटा होगा उसके नेक्स्ट में पॉइंट कर देंगे. ओके फर्स्ट ऑफ ऑल हेड रख लेते हैं. क्या करना है, दोनों में से छोटा कौन सा सबसे पहले वो. ठीक है, नहीं टेम्प को किसके इक्वल करना पड़ेगा, हम लोग को हेड के इक्वल करना पड़ेगा. ओके so we have our head pointer that is pointing to this first or this. Okay, so now what we need to do actually is okay, so बस दो लिस्ट था, दो लिस्ट में से फर्स्ट में जाएंगे तो क्या होगा, फर्स्ट में जाएंगे या सेकेंड में जाएंगे. राइट, I created this head variable head node for the sole reason of returning it at the end, right? Because you know I have to return a pointer that will point to the head variable. So now what I need to do is I simply need to check both are not equal to null. What we need to simply do is simply check, right? We simply need to check. Temp of next is equal to L1 next is temp of next is equal to L2 of next. Right, now if list 2 is not empty, right, and let class return the head pointer. I'm quite slow, I know, but it's okay to be slow sometimes. So okay, I'm getting a really short output. My output should have been this. Okay, okay, fine. So my head is currently pointing to good. Something, I have done something wrong, right? Hmm. Okay, let's print the values. Not able to figure out, so you know why not debug simply. So देखते हैं क्या print कर रहा है. ये print कर रहा है 2 1 2 and this one. So what I'm doing wrong? Printing the values correct, right? 2 1 2 3 4 3 4 4, right? So everything is right here. So I figure, I'm thinking कि यहाँ पर गलती कहाँ पर हुआ होगा. Temp of next पे गलती हुआ I guess. We don't need this actually, right? We don't need it. Node head, list node temp pointing to head, right? At last will return simply head. So okay. Okay. So I'm directly getting this runtime error. Insufficient space for an object of type list node. Okay. क्या गलती है, क्या गलती है? लिंक लिस्ट को कोड करना ही एक्चुअली टफ लगता है मेरे को. I have to overcome this issue because the interview favorite question is linked list, right? So देखो गलती क्या हो रहा होगा. लिस्ट नोड स्टार्ट टेम्प ऑफ नेक्स्ट. क्यों टेम्प ऑफ नेक्स्ट क्यों नहीं एक्सेस कर पा रहा हूँ मैं? फॉर सम रीजन नॉट एबल टू एक्सेस, राइट? टेम्प ऑफ नेक्स्ट L1. L1 is L1 of next, L2 is L2 of next, temp of next L2. Oh, I missed one thing. What did I miss actually? Understand? This was actually correct. Here I need to, also traverse, move one position of the temp to the right. Let's see, I guess this should return me the correct answer, and yeah, this is it. So should have got this error you know really fast, but okay, not a big deal. So what I need to test it on is, what if the two lists are actually empty? Let's check the edge cases on our own first. So if the two lists are empty, I should return an empty list, right? Pointing to nowhere, but it is not, right? So there's a base condition that I should include if L1 is equal to null, or L2. Okay, if L1 is null, return L2. If L2 is equal to null, simply return L1, right? Now that should run fine. Let's check it. सही रन कर रही है. लेट्स सी अगर इसमें एक एलिमेंट है, उसमें कुछ नहीं है, एम्प्टी है सेकेंड लिस्ट. ओके, सो मैंने किया क्या है, सबसे पहले मैं कोड को लाइन बाय लाइन समझा देता हूँ. मर्ज वाले क्वेश्चंस में मर्ज शॉर्ट में भी ये करते हैं, मर्ज लिंक लिस्ट में भी करेंगे. कभी भी शॉर्टेड चीज़ें आएंगे तो हम लोग का एल्गोरिथम एक्चुअली सेम ही रहता है. मैं सबसे पहले दोनों लिस्ट को तब तक ट्रैवल करूंगा जब तक दोनों में से कोई एक एम्प्टी मत हो जाए, राइट? सो I travel this list 1 and I travel this list 2 simultaneously. Not simultaneously, but at a particular point a time will come when the certain list, that is list 1, either the list 1 or either the list 2 becomes empty. So when either of this becomes empty, I simply exit this while loop. So what I am doing in this while loop is actually simply checking the elements value. For example, the first value of this element and this element is same, so we can include any of them, right? So I included, suppose, this one in my new linked list, and I moved the pointer to 2. Now I check 2 and 1, which is smaller, this is smaller, so I moved this pointer to this portion of the list, the next to the next. Then I came back to check 2 and 3. So 2 is smaller, then I moved to this part. Then I checked 4 and 3, so I moved 3 is smaller, then I moved to this part. And I checked 4 and 4. So suppose I pick this 4 because both are equal, so I can pick any 4. So 4 is picked by this, and this now points to null. And when this is actually pointing to null, I'll simply exit the loop. And now if you know that this 4 have not been processed, So what I need to simply do is check if any of the list has not been processed. I'll simply add it to my new list. That's it. That should run fine, I guess. Let's submit it. I guess it should run fine. Okay. Okay, so faster than 6.59%. That's quite low. So let's check out the discussion part, as I cannot say the solution is locked. Java 1ms 4 lines code using recursion. 14 line C++ solution. Okay, let's check it. C++ solution. So what he's actually doing is while L1 and L2 L1 well and L2 well, tail of next is L1. L1 is equal to L1 of next, else tail of next is equal to L2, L2 is equal to L2 of next, tail of next. So did I miss something in the question? I did not. So why didn't he include that case? But it's fine, I guess. This is the linked list, right? So instead of while, what I can do is if L1 is not equal to null, temp of next simply becomes L1. Okay, this was the optimization, right? Let's try to run it and check if this is working fine. Okay, this works fine. Let's try to submit it if I'm getting past the solution. Okay, now this has become 77% fast. Okay, now I understood it. So this question is done. Let's check some other questions now, I guess. Okay, 100 to go, right? We have 98 problems in the first page. I have skipped some of the problems, string printing, this all are quite. So generate parentheses. Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. Given n pairs of parentheses. Okay, these are the pairs, right? First pair, second pair, third pair, fourth pair. Okay, write a function to generate all combinations of well-formed parentheses. For example, given n is equal to 3 solutions, it is okay. Right. So when n is equal to 3, I have 3 closing brackets and 3 opening brackets. I have to arrange them in such a way that they are well formed. A well formed parenthesis is such a parenthesis we have solved a particular problem before. Where a well formed parenthesis is defined as such a parenthesis, in which a bracket, closing bracket does not arrive before the opening bracket. Right, if you see any of these, closing bracket always arrives after a particular opening bracket. We have a pair, right? So this question, is asked by many recruiters and all. I've seen this question asked by Google and all. So let's try to do it. Need to generate the vector of strings. So let's try to figure it out. So currently opening is equal to 0, closing is equal to 0. Vector of string answer, find answer. Void find answer. Now I'll pass. Okay. So first of all, if closing becomes greater than opening, that's a base case, right? I simply return. See, from this question, one thing that comes to my mind at first is I have to traverse through every path. This is a path-based question, right? So for to generate every path, the first thing that comes to my mind is basically recursion, not basically recursion, but backtracking. I have to generate each string and push it to my vector, right? So I need to pass n as well. So if n becomes 0, somehow I have to return. So it was a valid pair, right? If opening is equal to 0 and closing 0, I simply so I have to take a temporary string as well. It was not answer. This should be passed by reference, just to. So what I'm telling you to do is simply push back the temp string to the answer and simply return it. I'll simply return. So the question is now I have two options basically. Either to increase an opening by 1, either I can make an opening bracket or I can make an closing bracket. So if I'm making a opening bracket, right? Let's say if I'm making a opening bracket, opening closing answer and then I can go with opening closing answer and then. So 10 plus this thing right here, this thing right here, If at any point closing becomes greater than opening, I simply return because that path is not to be considered, right? That is actually not well found parenthesis. So here I missed this thing, closing plus one. So not particularly zero. Opening, closing is same. So what I'm telling you to do here is decrement and when you're closing it. Let's try to check once if I have written the correct code for recursion. If I'm not writing any error, memory limit exceeded. Okay, for some reason. Okay, so memory limit is exceeded, means that my recursion is getting or running forever. So why is it running forever? Because whenever this function is run, it comes directly to here, and sorry. Right. Right. So let's check it what my temp variable is storing. Need to debug. This can be done with stacks, I guess. Okay. Hmm. Okay. Now I understood one thing. both are 0 at beginning, right? None of the strings is of 6, length 6. Why so? I'm not able to figure out. 1, 2, 3, 4, 5, 6. Why so? There should be one then, I guess. Damn. Nothing seems to work. So I made a big mistake, a blunder somewhere. Not able to figure out that. So okay, here it comes. Let's try to put closing as well, right? I think somewhere I'm missing. CLOSING. Let's try to check my closing value of closing. Closing 1, 1, 1. Here it became 2 for some reason. Both are 0 at starting. Okay. So closing become 1 at this point. Closing become 2 at this point. Let's print the value of n as well. So it doesn't seem to work. But debunking. So what will make it work? Printing the value of n 3, 2. The value of n is 1 here, right? So why it's not going further down? Don't understand. Don't need to do this. It's 2 into n. Forgot 2. Multiplying 2. So that should finally work. If it doesn't, then no. So this works fine. Let's check the edge cases, right? What if the value of n is actually simply 0? I should return an empty vector. Do I? Okay, I return an empty vector. What if the value is, oh, Let's check it for 4. What I'm thinking is this will give me a TLE, right? Because value of n could be large as well, and the solution quite is seems like a DP is there. So let's directly write a DP. Let's initialize the DP. Let's pass the DP. If DP of opening closing is not equal to -1, return DP. What? Is it an int DP that you should be writing? It should be string DP. Right. Let's check. Okay. So done. While doing this, I need to take care of this case. Right. Here you need to pass DP as well. Let's try to run the code. That shall work fine, I guess. Okay, I'm still getting an error. DP of opening closing is equal to temp. Guess not able to store temp for some reason. Okay, what I'm getting is error is. So I need to int from. Is it int? Okay, check this string. Please work for me. Okay, I've assigned the value as -1, right? Empty string. It's not empty. Then we simply return the temp. I'm getting another. What kind of error is this, damn it? Overflow error. Let's try to submit it without DP once. Check if it is possible to submit without DP. It is. Just 12 minutes faster than okay. Let's check the solution as well. We can generate all true report 2 and sequences of images. We will check if one is valid to generate all the sequences with all the sequences. Okay. Use backtracking. So the first was quite easy, you need to generate every sequence and then check if that sequence is valid or not. We use the second algorithm, that is backtracking, which is quite efficient than the first algorithm, where you don't need to generate where you don't generate every possible sequence, but you generate that sequence which is going to be a string which has particular brackets in that position. So what I'm thinking to check is the complexity analysis says that the complexity analysis rests on understanding how many elements there are in generate parenthesis of our, and this analysis is outside the scope of this article, but turns out this is nth Catalan number. So everybody should know that what is a Catalan number, right? So let's go. Okay, more general form Catalan number. So let's Wikipedia. So what is a Catalan number? In combinatorial mathematics, the Catalan numbers forms a sequence of natural numbers that occurs in various counting problems, often involving recursively defined objects. They are named after the Belgian mathematician Eugene Charles Catalan, who lived from 1814 to 1894. The nth Catalan number is defined in the terms of binomial coefficients by Cn is equal to 1 by n plus 1 into 2n upon matrix of 2 vector 1 plus 1. Okay. The first Catalan numbers for n is equal to 0, 1, 2, 3 are 1, 1, 2, 5, 14, 42. Okay. So Catalan numbers is used for the length of the height of the binary search or something like that, which is bounded asymptotically by 4 to the power n upon n root n. Time complexity is this 4 to the power n upon n root n. Each varied sequence has at most n steps during the backtracking procedure. Space complexity. Closure number. So this is something new which I don't know of. Intuition says to enumerate something generally would like to express it as a sum of disjoint subsets that are easier to count. Okay, disjoint subsets is quite an interesting word here. Consider the closure number of a valid parenthetic sequence S, the least index greater than or equal to 0, so that S0, S1 is valued. Clearly, every parenthetic sequence has a closure number. We can try to enumerate them individually. For each closure number C, we know the starting and ending brackets must be at index 0 and 2 to the power C plus 1. The two ways to C elements must be a valid sequence plus the rest of the elements must be a valid sequence. Right. Okay, understood it. Let's read it once more. Hmm. Okay, this solution is quite simple. So okay, for example, DP is not valid here because the reason is actually very simple. We need to iterate every part to check if it is valid or not, but I guess some case DP would be applicable here, but let's not get into that. Is that word? Okay, I have to look something closure number. Let's see if there is some article about closure number. Let's see. Okay, so it's all about mathematics. Okay. Got into a good website, right? Good. Closure is when an operation on members of a set, such as real numbers, always make a number of the same set, such as adding on members. So the result stays in the same set. Okay, understood it right now. Understood it now. When we add two real numbers, for example, we get another real number, right? So it is in the set. This all is true. So real numbers are closed under addition. Subtracting two whole numbers. Okay, that is not closure. This is generally can apply to any sort of operation or any kind of set. Example: set of shirts. Shirts are closed with the operation wash. For the operation was the shirt is still a shirt after washing. For the operation rip a small rip may be okay, but a shirt ripped in half ceases to be shirt. Fine. So I have done two questions right now. I like to refresh the page because now I need to see that I have solved 22 questions right now. Merged K shorted list. Okay, let's do this one. Seems easy, right? I'll do the hard problem after in the next stream. Given a sorted array now, remove the duplicates in places that each elements appear only once and return the new line to not allocate extra space. For another array, we must do this modifying the input array in place with order of. Okay, so we have that. So there is a method called unique which I know about. Let's read it once. Try to use it here simply because I don't remember it right now. Now we need to resize it, right? From beginning to return the new length. Let's try to submit it. This was quite simple, you know. We just need to call the unique method faster than 31.21. Okay, what if we need to do it without the method unique? Okay, this is the question. Order one extra memory is what we have, right? Do not allocate extra space for and then you must do this by modifying the input array in place with. Okay. So I'll have to open -1. Else count plus plus, right? The first element is not equal to the second element. Okay, I'll do one thing more. Mhm. So need to remove the lens somehow. Okay, I need to remove it as well, right? How do I do it in place? I don't know. Without using unique, I don't know. Okay, let's see the solution. Hmm, this was quite good solution and simple solution. Point a solution. अरे, how do we not delete the element, right? It is not deleting the element. What do it returns at last? I plus 1. That's nice. Great. गलतियाँ कर रहा था, बट ये बेकार सोल्यूशन है तो ऑब्वियस सी बात है ना, जैसे पूरा अरे ट्रिम कहाँ कर रहा. If you see, we are not trimming. I'm just bringing the value of 2 to this place. 2 is also present at this place. Just copying the part of the. Okay, that is fast actually. Okay, cool. Fine. That's all. I have solved 3 questions right now, removing the tree. I'll end the speech and